Okay, welcome everyone. Yeah, I hope that the audience will be a little bit bigger, but anyway, I see a lot of friends here, so feeling relaxed. Hello everyone. My name is Piotr Plinkov. I work as a senior software engineer in Booking.com. So yeah, you probably heard of our company. We have quite a nice app, largest accommodation site in the world. But as all our other companies, of course, we are backed by SAP. So in our company, we are not driven by SAP. We have some ecosystem of in-house built solutions, such as billing platform, order platform, and all payment platform and other services. And SAP is used mainly as an accounting platform, but still is a very important component. And what our team is doing, we are solving different integration tasks, how we integrate our system SAP with corporate services. So, and my topic today will be about distributing tracing in ABAP with OpenTelemetry. So why I'm here. First of all, my session is not a best practice. Well, I would say I would prefer the best practice if it's use some standard SAP components, but I'm just sharing our experience. Second is, of course, it's very valuable for us. We went our own way, but maybe you would do it differently. To collect feedback, it's like one of the most important milestones. And of course, we want this out of the box in some form. So if there are some people from SAP, that's why I asked the previous presenter also if he has time to join this session. It would be nice if we can get some message to SAP that the topic which we talked about today is important. So this is the agenda. We'll go there first very soon. So first of all, what is the telemetry? If you, how many of you attended the recap event? Maybe, oh yeah, it's still a lot of people. So you saw even on recap with all this OpenStack Java, we had at least 3 sessions, 3 different speakers. We were talking about the same topic, traces, logs, and metrics. So because I hear myself, yeah, I'll stand here, not close. Maybe this one is still switched on. It's okay. So because I think it's right now, it's a trend in the world that all the companies are focusing on the telemetry. So what actually telemetry is? Traces. So traces represent some view on how your processes work connected to each other, what time each process take, where you have some bottlenecks, you can see it there. Logs, it's basically all the events just recorded in a system somewhere. And to measure our performance, we use different types of metrics. So basically, these 3 components are fundamental. Maybe I can just leave it a little bit far and I will not hear echo. So those 3 components. No. Yeah, because it's a little bit strange to talk and hear myself. Okay, it's okay. Yeah, so these are 3 components. So, and current topic is mainly focused on the tracing. So we also solved metric logs problem. We are working right now as POC on traces, or on the metrics, sorry. But traces is like something which we already tested and it shows quite good results. So what is the trace? Traces is basically a set of connected spans. Spans is those slides, right? So every span has a start, has end. This is the time. So this is how it's really shown in the time. The Gantt chart, basically, it's a Gantt chart. We can see some events. So some spans can have some events. And sometimes spans can be linked to each other. So for example, yeah, I don't know, different types of relations can be, but the main relation is the parent-child relation. We can see it there. So for example, span B is the child of the span A. So it's kind of a nested process. I took this screen from one of the provider, also telemetry provider Dynatrace, but I really like that slide. the checkout process, right? So the user clicks the checkout, request goes to the gateway. You can see, by the way, those colors which we see on the schema, they are also attracted in our trace that we can see the user black one clicks checkout, then our request reaches the gateway, it's a green one, then something happens on the front end, two actions, get current, initiate checkout, then one action reaches the cart service, another one reaches checkout service, both records recorded to the database, and we call the payment provider. So that's an example from the outside world, right? So what is then OpenTelemetry? So because we have so many right now solutions, I mean, open source, if everyone creates their own protocol, it's going to be a mess. So there was a community standard created which is called OpenTelemetry. So basically, OpenTelemetry is a set of tools developed by the community, mostly in the Go language. So they have a very large group, but it's adopted. First of all, it's already became an industry standard. So I think it's like SAP is not an exception. More than 40 vendors support it from the terms of the kind of telemetry, working with telemetry as a service. Yeah, it's highly extendable. The good thing, it's available in at least 12 different languages as SDK. So in your code, you don't need to think what is the protocol of sending the messages to OpenTelemetry. You just go in your you just write some function like log this event, and that event will be streamed to the OpenTelemetry provider in OpenTelemetry format with the help of that SDK. And of course, it has various integrations. So we can see that microservices, different infrastructure components send all the data to telemetry. Different clients also send their data, and they all stream to some databases. So that's a kind of high-level architecture. The core component of that telemetry is hotel collector. So OpenTelemetry collector is basically also software, exactly, developed by community in this Go language. So it represents like set of different receivers. So receivers, they receive information in OTLP format, which is OpenTelemetry protocol or Jagger or Prometheus. They transform those data somehow and then stream using exporters to the providers, which also support one of those protocols, OTLP, Jagger, or Prometheus. So, for example, just for example, how OpenTelemetry is implemented today in SAP. So we have our SaaS applications. Let's say it's a CAP application. We already saw that session a few days ago that we have now OpenTelemetry extension. It sends data to runtime collector, which is a software not developed by SAP. It's open source component running somewhere on their cloud. The same happens with non-SAP data providers. All data go to the cloud ALM. In this case, it's a kind of the service. And then data go also to the focused run application to visualize those data. But in this case, both focused run and cloud ALM, they represent some vendor software which supports OpenTelemetry protocol. So SAP has already adapted it. But here is the problem. Why I'm standing here? There is no ABAP. There is we cannot send data yet. There is no available tool. That's how we can send data from our ABAP applications to tools like focused run. So distributed traces and ABAP. Before I showed you the example with the process checkout, it's really somehow not connected to us. But let's try to think of some, I don't know, some example, sample process, right? So the user submits something on his Fiori app, like sends the order. We reach our OData service. OData service is usually, let's say it's an unmanaged wrap service. That unmanaged wrap service calls some BAPI function, for example, creates some document. Then we stream in the business event. That business event streams, publish it to the topic on the event mesh. In its own turn, payment platform is also subscribed to that event mesh. They received our event. They did some payment, whatever. Payment received went back to event broker. Event from event broker came back to SAP. We received it. Wrap saw this event handled, and we created one more push channel just to have a WebSocket connection in the same Fiori app. and the user see in few seconds, oh, my payment gone. But this is not a synchronous process, it's fully asynchronous. Question is then, how can we trace this process if we have like ODate, ABAP, business event, push channel, they all live in own different loops, right? How we can trace them? Well, I created, we still can do it. I hope that we can a little bit bigger audience. I created a simple Slido. We have enough time, we can do this. So can you please, with your mobile phone, scan this code? And then you can answer the question, which tools do you use to trace your apps? And you can also feel free to provide more options. So you respond once, but send, because we have, if we talk about ABAP, we have multiple transactions. Just put there everything what you honestly use in your daily operations to trace your ABAP apps. Or SLG1, good transaction. We can see there application logs. SAT, also very nice transaction. We use it. Or, okay, SLG1 becomes the leader. ST05, database traces, also very nice transaction. So, oh, I see already one of my favorite is ST12. Okay, guys, you just write in the most interesting moment. So I'll just repeat. If you scan this Slido QR code, you can also send the tools which you use to trace your ABAP apps. So we have now two leaders, ST12 or SLG1. Who wins? So ABAP cross trace. This is interesting. I never heard of this. Balog ST12. Yeah, that's what I say. Like that will work, but ST12 now is losing the because of this the one vote. No, I mean, if you use like commas, then it's a new answer. It's already not accumulating. Yeah, so gateway trace. But that's already a good picture. If you don't mind, I make it this. Do it like this. So the whole thing is we can see plenty of different ABAP transactions where we see different small pieces of the same process. And to understand what happens with my end-to-end process, we cannot do anything, right? So we really need, and that's why our team now has so many people, let's say, supporting SAP, because every specialist knows his own transaction, goes there, you know. So let's switch back to our presentation. 11, and then we go next. No, it's. I think I pressed the wrong button, slideshow. Yeah. So let's start from some kind of fundamental thing. So open telemetry in ABAP. So I used, like already mentioned you, what open telemetry is. So we have one of our rock stars, Lars Hvam. Basically, so I would first start with the system capabilities. What basically have RAR now in our system? I'm maybe not talking about Steampunk, but mainly about on-premise system, which is used by most of companies. So first of all, we have native JSON XML serialization, very good. So we at least have some protocols how we can stream data, but not everything, only those like really natively supported. We have HTTP client, okay, we can send information using HTTP. We have WebSocket connections, very good. TCP is available, but TCP is mostly to talk to devices, not to the services. MQTT, MQP clients represented, also working on top of WebSocket, very nice, because now we can use some protocol to how to talk to other services. And we have file system database capabilities also, let's say, one of the ways how we can store telemetry data. So one of the ABAP rockstars, Lars Hvam, created few open source projects. They called ABAP Open Telemetry, ABAP protobuf. Let's say there we didn't find end-to-end let's say, solution ready to use, because it's actually true. He didn't publish the exporters. He only proposed the idea, so that we can use class like this. So we start a new provider, we add the span processor. Then in that span processor, we create a tracer. We start a new span with this name, with this kind. We end the span, and we need to implement our exporter. So that was the idea. And we decided to start like our own implementation. It was not that much more work. So few fundamental things we had as our kind of core principles. So first of all, we need to spend minimum time on serialization, deserialization. Yes, I saw Lars, for example, use protobuf, but it's a custom serialization, custom deserialization. We already have on community many blogs about that. Identity transformation is almost unbeatable in terms of the performance. It is the fastest way how we can serialize, deserialize data. But we know the identity transformation serialize in IS-JSON format. So it all makes the capital case. So probably doesn't work for custom formats. Second thing, we want to use only native SAP clients, no custom protocols. So that's why in our case, we chose MQTT over WebSocket. We found that HTTP calls are too expensive, and later I will show you even the data proving that concept, that actually HTTP calls, if they are called synchronously, let's say if you stream every single event using HTTP, on a scale, we will pay with a lot of milliseconds, because when you receive the response from HTTP service, you basically wait for some small amount, but if you have hundreds of events in your process, you will pay anyway with your milliseconds. So we wanted to have also real-time analytics. So for example, ended span must appear even if we have a short dump or rollback. So for example, we have like business events. Business events, why are not really suitable for telemetry? Because business events come only after commit. But we also want to see if something bad happened before commit. Ideally, we need to see it. So, and of course, our framework should be extendable. So now I would like to go for some. First, I will show you what we did, and then I will talk about how it works. How to start? For my demo scenario, I created a little bit simpler component. So I created one HTTP service, which is search. So, okay, it's just called, scrolls, okay, it's just called like this, trace SRV, and it has this class. So that class it's a HTTP service, right? So this class is doing few things. So let's do it like this. I created some dummy task because we need to show some span in our. It should not take like it should take some time in our trace span. So I created some wrapper where I create the timer. No, I'm generating randomly the wait time between 0 and 1 second, so some milliseconds. And we also generating the span with some name, so we can see what we create an instance of our tracer in that context. Then we are using MQTT with this destination. Then we are starting span with this name, with this context. We wait for this some time, and that's it. So that's what this specific random span is doing. And then in our program, I will. Okay, it was a bad idea to put chocolate in. I go and I smell the chocolate. I really don't. I was trying to understand what response is. Okay. Yeah. Okay, we go on. It's how we do in ABAP usually, right? So condition change. We in our program, what we do, we run one span just in the same web service handler. Then we run few parallel tasks via ABAP parallel run, the topic which was presented before, and I also wanted to show some interesting data about it. Then we also run 3 tasks in BGRFC, TRFC, but sequentially. It means we run those 3 tasks in the same unit. And we also run 3 BGRFC, TRFC tasks, but in parallel. So that's what my service is doing. And also one more thing, because I wanted to have a custom authentication. So I wanted to make this service public, but it was not possible to do with this specific path, because new HTTP services, they don't have their own ICF node. So I had to create one more ICF node, which is just proxying request. It's called trace. So that service is proxying request to my service with with predefined credentials. So that was kind of the way how we make service public. So, and it also has own handler. That handler also has some small code how we I don't know, stream telemetry. In our case, we stream this event, span, get, booking, test, trace. So now let's see. What I'm gonna do right now, I'm gonna call some service, and I hope it will work. So I just need to run the collection. It's the service which I just showed. And let's choose the number of iterations 10. I really hope it will work. So Babam. Sure. Yes. But okay. Generate tests. Yes. Let me just take it quickly from the browser. Ooh. Yeah. Trace. It's this one. Okay. Yeah. So it just do something. I'll explain why I'm running it a few times, because we are connected right now to the real enterprise monitoring system, like a distributed tracing system. And I can send it like this, but I will still run it like 10 times, because we also apply so-called sampling logic, that we don't store every single trace, but maybe 1 of 10 or something, because otherwise we pay too much and we store too much information. So let's say 10. Right, run distributed tracing, bam. No, it doesn't work, but it's okay. You know everything, huh? Okay, so let's do one more time. Run collection 10 times. So let's see if it works. So yes, it's doing one by one. Perfect. Let's now go to our honeycomb system. So, okay, now let's talk about the vendor software. SAP is using Cloud ALM, Focused Run. Some companies use Dynatrace. There are open source solutions. My company decided to go with Honeycomb, so I don't complain. We just use the tool which we were given. So our software in the end, our ABAP program just sends event to this telemetry service. So, and then let's just, okay. My Okta token expired while I was talking too much. Just a second, some small delay. Yeah. Let's hope that we will see there something. Yeah, we have. So you see what, yeah, first of all, let's start like this. We run it, I don't know, many times, but in the end, we only received 3 traces. So I ran it like, if you clicked manually a few times, it's absolutely normal process as a part of that sampling strategy. So, and yeah, so let's start from this one, for example. So Is it possible that I remove this pane somehow? Maybe not, but we're going to talk a little bit about this. First of all, let me remove those columns. We start just with the, and I will remove the service name. It's not needed. We start with just the name of the span. Yes. So, and this is the best thing. So you remember we started from that distributed process when we have absolutely different components streaming data to the same thing. What we see on the screen? We see on the screen first HTTP handler, which handles is basically the handler of ICF node. This is the handler of UConn, this new HTTP service which we create with ABAP development tools. You remember we run 3 tasks in ABAP parallel. We also run 3 tasks in sequential RFC, because in sequential means it's one BGRFC unit 3 times we run the same function model in the same unit. Of course, they run one by one. And we run 3 times the same function model, but a separate unit, also as BGRFC. And here are the interesting things. So first of all, what we see from here, that actually ABAP parallel, it is true, it is parallel. We can see three tasks. Those numbers are random, I already explained in the beginning, because it's by default. I wanted to have some randomizer. But you can see that our process doesn't stop unless that ABAP parallel run ends. So basically it runs in parallel, but still stays synchronous. That's the whole thing. So we still need to wait when this parallel execution will wait. So that was one of the observations which we found. So if we want to go really like parallel and asynchronous, so we don't need to wait, then my recommendation is to go this way. Because you can see I started my BGRFC models and my my process, my thread stopped. It just doesn't work. While here, I started ABAP parallel processing, my thread was working because it was handling them. So that's kind of the important thing. Also, when you handle web requests, HTTP timeouts, solving HTTP timeouts problem, it's a different topic because you can have a load balancer, Envoy, some service mesh, I don't know, Nginx proxy, NSAP, tons of different timeouts. Where your service timed out, you need to investigate. That's why we try to make all our services to respond as fast as we can. Plus, using some events, we can also inform users later that something has changed. Yeah, so that was basically the result. I don't know if you find it nice or not, but you remember the slide on the left, different tools. So now our goal is to replace all those tools, the most important findings, with this new way of tracing ABAP programs. Let's move further. So what else? Yeah, so let's talk about how we did it. So there is no know-how. We used, is what I said, we only used like slideshow. We only used the open source components, not open source, the standard ABAP classes. So in our application, every single application is a different process in ABAP. It creates instance of so-called logger tracer in our case. And every time, every process opens the WebSocket connection. It doesn't close. It just opens, and unless the working process is working, it keeps it open and sends telemetry data. We checked the system parameters. By default, it allows 500 WebSocket connection, and that parameter is extendable up to 32,000. As a developer on the previous project, we developed a corporate kind of chat using ABAP system. I know that it's not a problem for ABAP to keep that large number of real-time connections to different users, so I was quite confident that WebSocket will handle this problem. So those of WebSockets stream information to our service, which we developed using Node.js. So BKS, in our case, it's a booking Kubernetes system, booking Kubernetes service, but to be honest, it is not really important how your Node.js or Java or one of 12 different languages code will work. And because it can work on the Cloud Foundry, sub BTP, or your own Kubernetes, or some virtual machine, or Amazon, depends on your choice. But the point is what we created. We created our own protocol, not OpenTelemetry protocol, because to implement real OTLP in ABAP, that would take us maybe years. But we implemented a very simple protocol only for the data we need, basically, and also which is ABAP IS JSON. So it's all, let's say, capital. Second, we created also our own kind of model, which basically this should be replaced. It's not booking telemetry. It's the best thing is OpenTelemetry API. We are using some open source component. In our case, we chose Node.js. That's how we took OpenTelemetry.js. If you go for Java, then you go take something else. And those data stream to telemetry provider. But of course, then if the more processes, the more application server you have, you need to scale it somehow here, right? So you need to scale your service directly. That's how we came with the idea that basically, if you put the message broker in between, it becomes a little bit better because message broker is scalable. It's a software which is created to accept large amount of messages every second. So we still stream our events using MQTT protocol to that event message broker. Then already set of our workers subscribe to the topic. I get the event, send to telemetry agent, and telemetry agent already publish it to telemetry provider. So here is the example of my code, which I just showed you before. So for example, yeah, we are starting the new trace. Yeah, we just say, okay, we use MQTT with this destination. And you can see my program also has a HTTP mode. That's how we could even check the performance and compare it between each other. So we create like a new span, start span something. For example, in my case, it was just some stress test span. And we end, sometimes we log some events. And when we do this, just in the moment of the log event or in the moment of the end span event, I guess this one, just at the same moment, we stream in the WebSocket message in the format which we designed ourselves. And by the way, we didn't open source this part, still under discussion. If we open source, the name of this will be ABAP Total. So yeah, but it's really like seriously this any developer can implement because it's not that much complicated. So okay, that was just empty slide. Yes. So this slide shows that code which we saw previously, how it works in Honeycomb. So basically, what we see on the screen, my spans took nothing. I was just generating them. So absolutely normal. They should take 0 seconds. But you can see the first span takes 72 milliseconds. Someone knows why? You have any ideas? Like maybe someone can guess why it takes 72 milliseconds for the first span? What, ABAP? No, ABAP is already compiled. Opening the port, opening the connection. So basically, a very first message which we want to send, we need to open the connection. So ideally, that connection asynchronously already should be created, but we just like this. And we did it like this, and our current kind of innovation or optimization will be reducing that amount by placing our Node.js proxy just on the same application server, so it will be a local host. Currently, it's a service which is running behind a load balancer on some Kubernetes nodes. Of course, the round trip takes some time. That's why it's like this. But it was the same number of spans. You see, 16 spans took 72 milliseconds. And now it's a very interesting observation. So I thought, okay, everyone tells me, why not using HTTP? Even AWS, we were telling me why you don't use our SDK with SNS, SQS. But if you go inside, it's a HTTP client inside, which every time sends the message and receives. And look what happens. Every single message, it takes 100 milliseconds in our case to send this message. And in the end, the same 16 spans already, instead of 70 milliseconds, they took 800. And it's only 16 spans. In real world, it can be much more. So that's why this picture shows kind of why we cannot use high intensity, high volume interfaces for why we cannot use HTTP for high volume interfaces. Yes, and there was one more way, also part of our experiment. We thought, okay, what if we, instead of sending messages directly to real-time channel, we store them in a database by, let's say, exporting to the shared memory cluster, or just storing them somehow in a serialized view. And then we also designed some, let's say, ABAP daemon, which listens to those new records and publish them. It works. But we also noticed that every single commit, if you really want to have it real time, it takes like around 7 milliseconds. But the point is, for 16 spans, it's a little bit better. But as I mentioned, if our process takes much more spans, using database is the, let's say, less efficient strategy than streaming them directly from your work process. So once again, as a conclusion, how did we achieve this? Custom telemetry SDK. That was we had to create some layer in ABAP, which is capable in an abstract way to record traces, logs, and metrics. Second, custom telemetry protocol. So we designed some own way how we send messages, because we made a decision we will not serialize a real-time protobuf message for OTLP. We better do it using identity transformation because it's faster. Third, WebSocket-based connectivity. Just previous slide showed clearly why WebSocket is preferable than HTTP. Yeah, if I'm wrong, just please send me some feedback, or just, yeah, I'm really honestly open for any advices. Custom Node.js proxy middleware in our case, and in your case, could be one of the 12 different languages which you can use to build your own kind of proxy layer between the serialized ABAP message and the OpenTelemetry. We hope if we open source our ABAP part, we will do the same for Node.js, by the way. So what do we miss? And this is a question, actually, it's was one of the goals for me to come here to be a speaker. Again, it was not a best practice. It's just our experience, our way. But it also was the chance to send the message to our SAP colleagues that what we actually miss right now in the standard code. So first of all, it's a truly asynchronous code. We show on the previous slide that ABAP parallel is not really truly asynchronous. It's still synchronous. It's like in JavaScript, we have that promise concept, and you have that promise all, promise race. So basically, it's promise all. You just wait and all of them finish. But we just want we need to have capability to call BGRFC. And for example, in case of ABAP Cloud, at least as of my knowledge, at some point, maybe 1 year ago, we couldn't use BGRFC in ABAP Cloud. So there was no way, only ABAP parallel, but it's not really asynchronous. So OpenTelemetry SDK would be nice to have out of the box. Yeah, we developed some class, but well, it would be nice, of course. But what is more important, what will be working behind that OpenTelemetry? So if SAP is capable to stream truly OpenTelemetry data in OTLP protocol just of our work processes, that would be just great. Protobuf support in general would be really nice to have, because OTLP is just one of the examples. But we see more and more services, especially with combination to gRPC or Kafka, requiring protobuf rather than JSON or XML, because it's, let's say, more efficient in terms of the message load size and everything. And of course, yes, that right now we are talking to using MQTT, but MQTT is the protocol which is designed actually to talk to devices. We chose it just because it's available. If there would be Kafka available, I would definitely go for Kafka, right? So because in our company, all the 99% of services talk to each other through Kafka. Only SAP cannot talk. That's why we right now solve this problem by sending MQTT messages, transforming them to Kafka, and streaming further to other services that they can kind of listen to us. And the gRPC, well, it becomes also very popular protocol. So, well, that for example, OTLP is built on top of gRPC. So basically, that's what we miss in the core. So if we will have this sometime in ABAP, one day, it will be really great. Yeah. So thank you then for listening. Yeah, maybe you have some questions.
Thank you very much. You said BGRFC is not available in ABAP Cloud. It is since the end of last year with BEPF.
Yes, that I've heard. So since last year, we started our research probably like August, September. By that moment, it was, so we already made decisions. So okay, we go for this technology. But I mean, I'm glad to hear that at least we can now run some parallel processes.
It's the problem of being too early.
Yeah, but anyway, we don't have cloud. We still use ABAP. Like our system is S/4HANA on premise. We had to find some solution which will work on our side.
I think the problem is that the BGPF, I don't know if it's available as for 2023 or if it just came.
It's another problem. Yes, was advised our company when we decided to go for upgrade. SAP as a vendor advised us not to go for the initial release of 2023. We are now with 2022, and probably in 2024 we can get it if everything goes well. So that's kind of the situation with ABAP upgrades, that also very difficult to get new functionality. But the principal thing, if you extend your ABAP core components in the same state as they are without any releases, with components on the BTP or any other technology platform where you can develop with OpenStack, then you're much more powerful in terms of, and much more flexible. You can reuse much more components available in the open source community. So that's the kind of core message.
Okay, thank you.
Yeah.
Any questions from the audience?
So I have one question. So this nice graph that was presenting to us, which of those three parallel tasks were executed in sequence, which of them were executed as asynchronous or pseudo-asynchronous, as you explained to us? Can we recognize which of them represents BGRFC call, which of them TRFC? Can we find this type of?
It was because it was not a slide. It was a live demo, of course.
Demo, yeah.
It was a live demo, and let me just go out of the presentation mode, and it was this. Yeah, right. F11. So this is the thing. You joined already. You saw this slide or not? When you came, no? So maybe I'll just repeat one more time. I had a program which calls ABAP parallel class, and we now have the data showing that our parent thread will not stop unless the ABAP parallel will finish. And at the same time, if we run the parallel BGRFC, our program doesn't stop, it just finishes, and those guys work. So yeah, I just
okay, but the question is which of those three, because as I understood, and maybe I got it wrong, yes, that one of those processes is BGRFC, another is TRFC, and the third one is another kind of RFC.
First of all, this 1, 2, 3, it is the same logical unit of work. No, it's not the same. In this logical unit of work, I call it ABAP parallel. We know that ABAP parallel inside calls IRFC. So technically, it's in different processes. This, and this. It's 3 different tasks running in asynchronous RFC, but we still have an ABAP parallel, the statement, wait for asynchronous tasks. Only when they finished, we come back saying it's done. This one, I ran as a maybe still it's a live demo, and the code is there. I hope my session still stays alive. Yeah, that was the code, right? So where is it? The class builder. Yeah. So you see random parallel tasks. Oh, that was the first one about parallel random TRFC tasks. So basically, what it's doing, I created a function model with just one function, random span, the same function, and I'm calling it in the background unit, right? So that is BGRFC, background unit. But the point is, it depends. What is this unit? Do you create it every time new unit for every single call? Or you have a chance also, you can run the same function model 3 times in the same unit. Then it will be kind of a queue. They will run first one, wait, second, third, and so on. So one time I run it in a parallel, one time I run the same function in sequence. And now let's see what
using one single unit.
Yes, so I will show you. Sequential using one single unit, parallel using new unit every time.
Yeah.
And we can see it here, right? 1, 2, 3, 1, 2, 3. I totally forgot. So one more thing I will just quickly add. So when I'm sharing my spans, I also do one more. We are capable to provide custom analytics. So what we get EPP. We get a few GUIDs, which EPP is extended passport policy. EPP. I don't know what is this. Yes. So what we take? We take some connection ID. We take some transaction ID, sub transaction ID, and there is a context ID. But let's do something like this. So you can see some GUIDs. Our tool allows us to do something like this. So let me please color based on the, yeah. We can see that the whole spans, they belong to the same transaction ID, even they run in a different completely. So one web service calls another web service. That web service calls IRFC. IRFC call, then that web service also calls some BGRFC, but they all run as one transaction because SAP internally has this GUID saying like it's the same transaction. Passport, yeah, then I was right. And connection ID already slightly different. So let it just maybe, I don't know why it's not that reactive. Or no, it is the same GUID, it's the same. But the point is why I'm showing this. If you go, those GUIDs, you can also use for the troubleshooting because both transactions, there are a set of transactions which support extended passport policy. So one of this is ST22, our favorite transaction for favorite. I would prefer not to know about this, but sometimes we have to analyze raw dumps. Transaction ID, EPP root context ID, EPP connection ID. So those 3 GUIDs you can use. So if you have short dump and you manage somehow before that short dump to send some telemetry data, at least you will get that ID. With this ID, you will be able probably to find the short dump. So it's a very good thing. And also another transaction which has even more information. That's a very good one. ST03N. Which shows you some workload monitor, right? So if you go to detailed analysis, like business transaction analysis, you can also use this root context ID, connection ID, and transaction ID. So just as example, let me please try to take that transaction ID we just have right now here. I'm not sure, by the way, if it works or not, so we can just do. The only thing, what was, let's use the 10, right? So, because I don't know what was the exact time, and nothing found. Am I right? It's the 6. And if we use the... I'm sorry, it was, yes, end time is like... okay, just let me see, what was the time? The time was like 9:43, which was 11:43 actually. So it was like 11, let's say 40 to 11:50. I should be, because it doesn't allow to go too wild. Somehow some limitation shows this. And what is also interesting that this transaction doesn't show everything what we had. It only shows one of HTTP calls and only shows the ABAP parallel. But it doesn't show, for example, BGRFC models. Even we already know they were running in it's RFC calls, and they were running inside ABAP in the same transaction. We have this data, still not visible here. So that's how our distributed tracing now brings us even better visibility than standard SAP tools give.
Okay, thank you.
Yeah.
Did you check in any way Cloud LM? Because it's freely available for every SAP customer.
What is this? Cloud LM. Well, maybe it's the next choice, but let me please explain the idea of that thing. We have a business value behind it. The point is, SAP in our company is just one of the hundreds of different services, and 99 of 100 services already streaming data there. We want to know, someone calls SAP, and for them now we are like a black box. They have all the logs, but wherever it touches SAP, bam, disappears. We just get some strange error code which we take from the application or from that standard SAP, and that's the only error we give. Now, right now, they will be able to see our execution also in their traces. Basically, the whole idea of this telemetry is that every single process works in some context, and your task to propagate that context across all your programs. That is the whole thing, right? So, yeah.
Because in the meantime, where I talked, I just set up the Cloud LM integration to my other development system.
But if we stream their data, we will see only our own traces.
I got you.
Yes, so that is the reason. That's the whole concept of distributed tracing.
So, thank you. Any further questions?
And how do you connect this SAP data now with all the data from other systems that use the same, for example, order ID? Because at the end, it's an order ID that goes through different systems. How do you get the connection between those?
Let me please explain. When in OpenTelemetry, when we propagate the context, we never propagate order ID or something. We give a very abstract trace parent ID. So we give the context of the trace ID, that we are in this trace, that all spans connected. We give in the context the ID of our parent span. Let's say some service calls us. They say, we have that trace, we have that ID. Our task is just to start spans, not as a new tree. We can also do this. But if you want to really support the distributed tracing concept, our task is just to start a new span as a child span of that ID. But we don't even know, I mean, what is the context from the business value. It should be provided you as a business input parameter, right? Some as in a body or in a header or in a URL. So like as a part of your API. But trace parent is just usually it's HTTP header, and it's really like very abstract thing only as a context of your trace. So
it's an import parameter of
it's usually used as a in HTTP by default. It's really like how this is as a spec protocol, not even not supported by OpenTelemetry, but by the whole HTTP community. It's called trace parent. You can read about this, and of course later we call some BGRFC functions. We call some to start some batch jobs or whatever, submit some programs. It's our responsibility then somehow to propagate that. Or as idea, didn't yet implement, maybe we can keep that trace parent somehow linked to EPP passport in some custom table maybe. And then because we have a lot of standard programs, which probably difficult to extend, right? Just for the context. But we have there one of those three GUIDs, and maybe by those GUIDs we can find a trace parent. It's just one of the ideas we thought but didn't yet implement. Yeah.
So, next question, or?
See the group of five people, they're really bored. Maybe you have guys some questions.
No? Yes? No? Huh? No?
Yeah, it's such a shame.
The young ones, they're too shy, you know?
Yes.
So, In that case, thank you very
Thank you so
much
much.
for your
Thank you.
time, for your good presentation.